Hello, and welcome. Happy Thursday. Welcome to another NATS Office Hours. Today, I am joined by Samuel Attwood, a developer here at Synadia. And Sam, do you want to... Well, first of all, Sam and I got back from KubeCon last week, or KubeCon, however you pronounce it. But that was an awesome time, just kind of chatting with a lot of NATS users, a lot of people doing really cool stuff with NATS and deployments and scenarios that I hadn't heard of it being used in. And so it was a great time. But Sam and I got to hang out quite a bit at the booth, and we nerded out over Homelab stuff, which I've had a couple instances of home media server type stuff over the past, 15, 20 years. I've used Plex, I've done some torrenting stuff in the early days, but I've never really had a full Homelab setup. And I was fascinated talking through not just your home lab and kind of the, all of the capabilities that you've set up, but also how you're using NATS to facilitate communication within your home lab. And so I thought today would be a fun time to take this office hours and chat a bit. Sam does have a meeting in the back half of the hour, so he'll be joining us for about 20, 30 minutes here, and then we'll kind of segue into more general office hours, Q&A, maybe just continuing the home lab discussion. Maybe I start shopping for parts for my home lab. We'll see where we go with it. But yeah, do you want to start by just giving a little bit of your background and what you do here at Synadia?
Yeah, so as Nate said, I'm an engineer here. My background was largely infrastructure and DevOps, but currently I do a lot of development on the control plane and Synadia cloud platforms. Yeah, I come from my first job. I worked in a data center at my university, setting up networks and handling virtualization, and then worked on autonomous boats for a while for the Navy, and then worked at SUSE for a little while, and now I'm here. Yeah, it's been a great place to be. So yeah, as Nate was saying about KubeCon, it's so much. This is my second KubeCon with Synadia. And it's so much fun having people come up and talk about how much they love NATS, how they're using NATS in all these weird, interesting ways. People come and be like, "I'm using NATS, but you've probably not like anyone else." And we're like, "I've heard that before." And you'll find us running at huge scale in these in classified projects or in these really interesting back end ways that are just fascinating. And we always reach out to us. We'd love to talk more to you and find out more about your use case. So that's always a really good time.
And it does look like the stream misfired on YouTube today, but we're already into things. We've got the recording going, so I think I'm just going to upload the recording after the fact to YouTube instead of taking 10 minutes to restart things and pray it works again. So
fair enough.
No worries there. We'll just keep it rolling. If you are joining us on Twitch or on Riverside directly, as usual. Oh, wait, I do see... No, that was the Stream Elements bit. But yeah, as usual, feel free to drop comments or questions in chat. We'll be reading those as I go. Although, like I was saying, we've only got Sam for about half an hour here, so I may save some of the Q&A section for the tail end of this time, or we can discuss things once Sam drops off. But yeah, so sorry, I kind of cut you off there.
Totally good. Do you want to get into home lab stuff, or?
Yeah, let's do it.
That was actually a good segue at KubeCon. It's often a really... People light up if they're into home labbing and they find out you're into home labbing. People get really excited, which I totally get. I'm the same way. It's just very funny. There's quite a community of people out there.
Yeah.
I got into it a long time ago. I first started running servers at home in 7th or 8th grade. But I really got into labbing probably later into high school. For a long time, I ran a lot of enterprise Dell equipment. I had full server stack, full depth rack mount servers and data center switches and stuff. I've downsized a bit, largely because I've containerized everything and because low power computers have gotten quite good and quite cheap. While I still have kind of a love for that enterprise stuff, it's not always the most practical, and you can go very far with much smaller nodes. But yeah, currently almost everything I run is on Kubernetes. But yeah, in the NATS sense, so I run NATS using our Helm chart deployed to my Kubernetes cluster. So as everyone does with home IoT, I run Home Assistant. I have a Z-Wave and a Zigbee network. Do you know much about the IoT kind of major protocols for the wireless protocols?
I know a bit about Zigbee for lights, MQTT for messaging, but let's do a quick overview for anybody who's not.
Yeah, so Zigbee and Z-Wave are two of the big ones, and then there's some newer protocols that are built on top of Zigbee which, wow, right now my brain is failing me. Wow, why can't I think of it? There are some new ones that are like meant to be. Some of the major players like Apple and Google and Samsung are kind of joining up to try to standardize a bit more. And so Matter and Thread are new ones. I believe they are primarily running on top of Zigbee, but they have they can use, I think, multiple protocols. So far,
Okay.
a lot of those devices to me, have felt a little early stage. So I've stuck with Zigbee and Z-Wave. Z-Wave, the downside is they tend to be a little more expensive because they have to get certified. Every device has to be certified. But the benefit of that is they tend to be pretty reliable. So,
Sorry, that was for Zigbee. It's got to be certified. Z-Wave, not so
Z-Wave.
much.
Z-Wave needs to be certified. Zigbee is a spec you have to meet, but you can put out a Zigbee device without going through the like Zigbee alliance.
Got it. Yeah.
And so some of them are, not as good at implementing the standard. And so you can run into devices that are not quite as reliable. Z-Wave tends to be more reliable because all the devices are certified, but as a result, they tend to be a little more expensive. I run both. There are other protocols out there, but I try to stick to those two because they're kind of the biggest in terms of device availability. And also, I just don't get way out of control having tons of different radios and stuff. I only need the two radios, and it makes life a little easier. Oh yeah, all my
So
devices.
does that require a base station for each of those? Do you have a hardware base station
Yeah,
for Zigbee?
I actually have USB radios for each that plug into just one of my regular Linux servers, but there are like loads of hubs out there like Hubitat and many others that have those embedded and you can use their own platform. It kind of depends on what you want. I like to tinker, so I like having just the radio itself and then I can kind of use it however I want to. When you look at IoT devices, you'll find that every company has their hub and they're like, this device requires our hub or whatever. And you find out their hub is usually just a little box with a Zigbee and or Z-Wave radio running whatever their software is. It's not, for the most part, they're not that special. The software they're running is, they all have different approaches to how to automate things, but the hardware itself is pretty standard. Anyway, so I run, those two radios. They come into some open source projects that manage. So I use, Zigbee to MQTT and Z-Wave to MQTT. And then my MQTT broker is NATS. So I run my NATS cluster in operator mode, obviously with MQTT exposed and with Jetstream. And you can point at, MQTT v3.3, anything up to that, you can point at NATS and it will just handle it like native. Like, you kind of flip a switch, in the config, and it really just works just like if you were running, Mosquito or whatever else. But I always love that I can do like a NAT sub and I can see all my house's messaging traffic and see like, lights changing or sensor updates from thermometers or, door close sensors or whatever else. It's just fun to be able to see that all in NATs. And then my NATs cluster, which like I said I run a 3-node cluster on Kubernetes. I have it joined to Synadia Cloud in 2 different ways. I have it connected over Private Link, which is for our bring your own NATs, so I can see all of my metrics and alerting and manage my distributed auth and all those great things. And then I also have it leaf noded to NGS, so I can actually do stream sharing and whatever else I want to do. So I actually have my lab connected 2 different ways into our platform, which is kind of fun. I also love this because having my lab in Synadia Cloud is a real world use case of how I'm using NATS and is a practical use case of our cloud. Like, I'm able to experience it as customers are. So I kind of get to, dog food, which is always good. Obviously, we use it a ton in development, but it's nice to have a real world use case of, this is how I'm actually using NATS. I'm going to join it, and then this is my experience of managing my actual NATS cluster. And I've been very happy with it. So I'm glad that I've been happy with it. But yeah, I mean, NATS is bulletproof pretty much. So it's been a great experience. I also had some other ideas that aren't just IoT, but I was working on, or I think I might still finish this, but a core DNS module for NATS. So using NATS as basically the DNS backend. A while back, a bunch of my friends who also had labs, we did a BGP mesh between our labs over VPNs. And
Really?
What's that?
Just I haven't heard of BGP for quite a few years, but doing a
I mean,
BGP
BGP still
across.
runs the internet. You just don't see it.
Right.
It's still
Yeah.
handling
No.
all the routing. But yeah, anyway, we did that, and I wanted to have a kind of distributed DNS for us, and so that was
Right.
fully implemented. But I had started work on it, where I was going to use NATS for that because I could, I could mint JWTs for everyone with restricted access, and so they could all, push your own updates to, whatever subjects for your own. My idea was to use subject addresses as reverse domains. So you do like, com.synadia. And so you could,
Right.
and then I could give access to whoever owns that domain to, that would be on their job, and so they could push updates, but they couldn't push updates to
Interesting.
anyone else's. If I finish this project, I have some other ideas, but I still like that. I think that would be cool. And then I don't know. I think you know this. We talked about it at KubeCon, but there's a NATS integration for Kine for K3S, right? So you can use
Right.
NATS KV as the etcd replacement in your K3S cluster. And I'm just like, how much of Kubernetes could you replace? The operational parts of Kubernetes could you replace with NATS? Because core DNS is also a core component of most Kubernetes clusters. So I think it'd be kind of fun
Right.
to do like the NATS Kubernetes cluster. But yeah, anyway.
I'm going to screen share here. I'm taking a couple notes, but I'm going to back you up and try to talk through this a little bit. So maybe we could diagram out some of this.
Sure.
But you've mentioned, so using NATS in a couple different ways here. So primarily in your cluster, using it as the MQTT broker. And then you're also using it for general communication, right? I guess.
Yeah, I mean, I use my local NATS cluster for lots of development stuff too, right? Anytime I need NATS, I'll either spin up a local one on my laptop or I'll just point at the one that's running in my basement.
That's what it was. You were touching on the two ways. You're doing what was it? A bring your own NATS?
That was for how I have it connected into our cloud platform, right?
Right.
You don't have to use NGS. You can bring your own NATS cluster. So in this case, I'm bringing my Homelab NATS cluster using private link and connecting it in. So it shows up. You get the full hosted dashboard and everything that comes with it, and I can use it to help monitor and manage my cluster.
Okay, so you're using private link to have your local NATS cluster be connected into the cloud and the platform tooling, right? So use private link to share on-prem cluster.
If you don't know private link, it's our solution for how
tunnels
you can,
the traffic.
Yeah, it actually uses NATS to break through a NAT network address translation layer. Well, I mean, you don't have to have a NAT, but it just connects your cluster into Synadia Cloud so that you can see your own self-hosted cluster, but still use all the benefits of the hosted control plane platform. And then, obviously, also we have NGS, which is our massively distributed NATS cluster, and then I have it also leaf noded to NGS. So I have two different ways that I can kind of link up with Synadia Cloud. Then those do different things, right? Private link is so that you can monitor and manage your cluster with our hosted platform. Leaf node to NGS allows me to use NGS, but have that local leaf node here. So like if I, for example...
That's where you're replicating, basically. So your cluster
there are a lot of ways you can use leaf nodes. But like, let's say I was hosting some service, some NATS microservice in my Homelab here. If I talk to it locally, right, via that leaf node, it'll just, and let's say I have one here and then I also have one pointed at NGS directly. Whenever I'm home, it'll use that local one because it'll always route to the lowest latency. But then if I'm somewhere else, it can either talk to the NGS one or it can use the leaf node connection and talk to the one that's here via NGS. Leaf nodes act like they're a part of your cluster, but they're still kind of their own piece, right? So it works great for edge use cases, there are a zillion ways you can use leaf nodes, but that's kind of an example.
Yeah, but it's the selection that's super nice that, anything you're doing locally is naturally going to go through the leaf node. It's not going to have to incorporate any latency. But then when you're away, which was one of the coolest parts at KubeCon, was you showed me live. You're like, all right, well, now let's pull up the stream and we could see all of the traffic going in real time.
Yeah,
which is pretty
powering on and
rad.
off my lights and stuff from Salt Lake City.
Yeah, so you're using NATS to connect everything. You're using NATS for um, the MQTT broker that's handling all of the Zigbee and Z-Wave traffic. You were talking about using it as a DNS module, which you
Yeah,
haven't really done yet, but that's
I had a module that was probably, I don't know, 30% of the way there. It was working. It just wasn't. I never finished. And then our B we all kind of moved on to different projects, and so it's just one of the
right.
ones that didn't get totally finished. But I might go back to it sometime. It was kind of a fun concept. Yeah. So there's like you've got it there. The kind integration is definitely a big one.
Yeah, that was another. Yeah, so Kine is K3S. I love these acronyms. Kine is not
Recursive
etcd.
recursive acronyms. Yeah.
Awesome. Okay, so this is where there's already a NATS integration.
Correct.
So
Yeah.
if you're using K3,
So this is something that Delaney has worked on. I think Delaney has worked. Yeah. Or
that's
is he
awesome.
working?
Okay, so it's pretty straightforward to connect that in.
Ireland has worked on it as well. Yeah. Yeah. No. So this is already in SUSE's repo here, and is available for use.
So
And
you
then
wouldn't
there's
even have to
also
do much for the etcd replacement. That tooling's pretty much done.
that's already there. Yeah. You could run K3S today with NATS as your etcd replacement. That's already possible. It has been for a while.
All right. So stepping back to see if we can live diagram this out a little bit. Because again, we might have viewers who are unfamiliar with a home lab and kind of what that looks like.
Sure.
We could
Well,
start kind of
home labs
chatting
can
through.
take many forms, but I can certainly tell you about mine.
Yeah, I was gonna say we could start with features and then talk down from there, or if we want, we could start at the bottom with like hardware and diagram out a little bit of your actual setup. Start from the hardware and go up. What do you think
Sure. I
makes
mean,
more
that's
sense?
certainly easy to talk through. Like I said, labs can take a lot of forms, and mine has taken a lot of forms too. I used to run big virtualization stacks. I ran vSphere clusters for many years. Right now, or I don't know if you want to start. You can start talking. Right. So right now I have primarily 3 mini PC nodes. Right now they're running Talos, which is a OS that is built specifically for running Kubernetes. It's immutable. It's pretty great. I was talking to people about it at KubeCon as well, because I think a lot more people are learning about it. But it's very cool. Unfortunately, I can't easily run Talos with Kine on NATS, but maybe I could. Maybe in the future there'll be a way to do that. Right now, it's a K3S integration. I used to run K3S on OpenSUSE.
All right, so you've got 3 nodes, and these are all connected, clustered with K3S.
Not K3S. I forget if I think Talos uses upstream Kubernetes. I don't recall exactly which distro they use. But if you want to give a hypothetical so we can show how the Kine integration works, we can say that they're running K3S.
No, that's fine. Let's stick with your current topology. So we've got the 3 nodes. They're all using Talos.
Yep.
Together, these constitute a NATS cluster, right?
Well, they constitute a Kubernetes cluster. So in my case, these are all control plane Kubernetes nodes. Because I only have 3 nodes, they're running as control plane and worker nodes, which in production you usually wouldn't do, but I would need more nodes to do that, and right now I have just 3. So these are all connected over just a 10 gig backbone link to each other, and so in this case, obviously they're running the standard Kubernetes components and etcd and the API server and all that stuff. Now I've deployed the NATS Helm chart to them, so there are NATS pods running on these. Now,
okay,
due to distribution rules, there will generally be 1 NATS pod per node because they're topology spread constraints. So you can encourage Kubernetes to say, hey, if you are able to try and spread out these pods so that if any one node goes down, I don't lose multiple pods simultaneously. So yeah, generally speaking, there will be 1 NATS pod per node. That's not 100% true 100% of the time because Kubernetes is a scheduler and pods get moved around. But given that all nodes are healthy and available, that is how it will be deployed. That's a configurable thing.
Okay. I'm trying to figure out how to show. So we've got the NATS.
Totally, I appreciate you doing the diagramming here.
So we've got NATS running in each of these. That's all deployed with the Helm charts, which you have put together, by the way. That was something that was cool.
I can't definitely take all
but
the credit. Caleb did a lot of the work on the new Helm chart, but yes, I do work on the Helm chart.
So each
I
node,
love our Helm chart, but it is a different approach than a lot of other charts take in terms of how customizable it is. And so sometimes people have
yeah,
questions because they haven't run into the patch merge mechanism. But for anyone who's seeing this, almost pretty much everything in that chart can be modified by you if you want to. So if there was an explicit setting in the old chart that is no longer in the new chart, you can definitely still set that thing. It's just it just might be a little bit different in the value channel. But it's actually much more flexible. You can kind of modify every component if you need to. It's very slick once you get it. It's a little different than a lot of other Helm charts.
which is a shout out for anybody watching. If you have questions on the Helm chart, or if you if you want any tips there, definitely hop in chat and ask while Sam is here.
Well, and we also have the Kubernetes channel, the KH channel in the open source Slack, which I monitor, and many of us monitor. So if you have questions there after this, feel free to please join us in the Slack. It's a good place.
And I will link that in all the chats as well. If you're not already, definitely please hop into slack.nats.io. Yeah, we've got, I think, like 9,000 people in there or something. There's a pretty big,
it's quite a few people.
Pretty big Slack channel there. But yeah, if you're looking for support, it's great. And like you said, there's a Kubernetes channel in there. Okay, so each node is running a NATS server, which in summation, again, visualization is a little bit funky here, but ultimately what that gives us is a NATS cluster.
Mm-hmm.
And this is like your on-prem cluster, right? So this is where these are all, this may not be the best visualization, but ultimately these are all a part of this cluster.
They're all the Helm chart takes care of this for you, but they all have routes for one another, right? So there's a route between every node to every other node. And that's true. You can scale. I'm running 3, but you can scale beyond 3, and that will still be true.
So technically they're all networked together. This cluster in the middle is like an ephemeral construct more so than a literal construct. But I do that because then we can link this with big picture. Let's go back to this blue here. We've got cloud. And this.
So private link also is running as pods on the Kubernetes cluster. So it's able to talk directly to my NATS nodes over the overlay network in Kubernetes, and then links out to Synadia Cloud.
So the private link is kind of like an add-on piece here, right?
Yeah, but it's running just as a pod on Kubernetes as well, just like NATS is, right?
So should that be a separate?
You can diagram however you want. I just trying to be clear that this is just containers running on Kubernetes.
Right. So private link pod, and that is what's funneling traffic over to Synadia Cloud.
Maybe this is just me being a developer of private link, but I feel like the arrow should go the other direction. Private link kind of makes the connection, but it's not that's not that important.
No, that's good. It's good to get these things accurate because so private link is connecting to your local NATS cluster, and then it's tunneling traffic.
And so basically the way that it works is that when the cloud platform needs to talk to the NATS cluster, it can make a request to private link, which has a NATS connection established. And it can say, hey, I need a connection, and then it will set up a tunnel between the backend NATS nodes and the Synadia Cloud client. And so it facilitates just regular NATS communication.
So the private link pod is reaching into the cluster to get that info and then tunneling it across. So you have your Synadia Cloud UI, and then we also have actual NGS, which is its own NATS cluster, right?
Yes. So then in addition to private link, I also have a direct leaf node connection from my NATS cluster to NGS. You by no means need to do both of these. I wanted to do both of these, and it really depends on your use case, what makes more sense for you. But there's no harm or downside to doing both either. They don't conflict at all. They kind of serve different purposes.
Yeah, no, 100%. So it's the NGS cluster. This is a topology strategy, right? Ultimately, this is replication where you have NGS, Which then are these pretty much, yeah, so these are two clusters in a multi-cluster, right? So you've got your NGS cluster, and then your local cluster is set up as
So it's
one
in this
leaf
case
node,
we use the term leaf cluster because it's not one
leaf
node.
cluster. Right.
But yeah, they are discrete, unique NATS systems, but they're connected together, and so I can do whatever amount of sharing between them that I'd like. So I could like replicate the MQTT, because has statefulness, is running on Jetstream underneath. I could like mirror those streams to NGS. I could do stream sharing. There's any number of ways I could configure this where if there were pieces of the lab cluster that I wanted to have access to globally via NGS, I could share, or there are a bunch of different ways that I could have those available on the NGS cluster as well.
Right.
So right now I haven't had a persistent use case for my home for that, but I plan to. In the future, then if I'm like away from home and I didn't want to expose my personal NATS cluster to the internet, I could share out whatever streams or subjects or whatever I want to NGS via that leaf node connection. And then if I'm away from home, I could just connect to NGS and then could have that traffic flow via NGS back to whatever I need at home.
And now, correct me if I'm wrong, but the implication there then is you can have more fine-grained control over the traffic on the leaf node as well, so you don't need everything.
Yeah, I can share as much or
cluster.
as little as I want to with NGS. Having the leaf node connection set up isn't implicitly giving access to things to So any accounts I set up on NGS, I can determine both what control that account has, and then also from my own cluster's side, I can decide how what I want to share from my accounts to the NGS accounts. So there's a lot of fine-grained control you can have.
Yeah, and this diagram's definitely gonna be a little bit messy here, but trying to think, because it's the NATS on the nodes, but then the other piece that it's doing is additionally all of your devices, right? And so
yeah, and so all of those, I've got I don't know what I'm up to now, but I've quite a decent number of Zigbee and Z-Wave devices across my house right now. All of those, obviously, traffic flows over the air to the radios for those, and then is immediately sent as an MQTT message to NATS. So there's a server, one of my servers. My Zigbee controller runs on Kubernetes. My Z-Wave controller currently doesn't, but both of those are running in my basement. And then so the traffic from the devices themselves go over the airwaves to those radios and then are sent off to NATS. And then I can do kind of whatever I want with those, right? Because so many of these different integration softwares have a way to integrate with MQTT, it makes it very easy to get messages where you want them to go. Like I use Home Assistant, but I also want my home stuff to work in HomeKit on our Apple devices. And so I have a bridge for that, which is also connected via MQTT. And so without it having to talk even to Home Assistant, I mean, I can if I want to, but it can just go based on the MQTT messages, because they'll, NATS will route them, wherever they need to go, whoever's listening for those messages.
Right. So I don't know how helpful the diagram is, but I feel like this makes things a little bit more concrete. So you've got your MQTT devices going into the radio, and then all of that ultimately goes through the cluster. And I assume that that's like transparent in terms of which node that is. I mean, I assume you have the radio plugged into one of the nodes.
So when it comes to like this is like standard kind of Kubernetes ingress stuff, not ingress in the terms of ingress controller. So basically, I run Metal LB on my lab. I don't know if you need to add a node for this, but it lets me use load balancer resources locally. I can give it a portion of a subnet, and it can automatically allocate IP addresses to load balancers. So I have my NATS cluster service exposed as a load balancer, so it has its own IP address, and then gave it its own DNS. So you can connect to like nats.attwood.dev locally. That's not publicly exposed. So I can just point everything at that, and then it'll go to the load balancer, and then Kubernetes handles kind of round robining to which node actually handles the request. But to the endpoint, it doesn't matter. It's transparent.
Yeah, I don't even know where I'd put that in here, and I fear I'm starting to make the diagram a little bit too complex.
Most of that is pretty. That's not NAT specific. That's just Kubernetes stuff, right? You don't have to use
Right.
load balancers. You could also use like a node port exposure. There are a variety of ways you could expose it, but that's true for any Kubernetes service. You could even go through an ingress controller if you were using WebSocket, but generally NATS prefers to be directly exposed if you're going to make native NATS caches. Oh yeah, and this is MQTT as well, so it's a different port than the standard NATS port. But
Sure. Yeah. Yeah.
this is like kind of just general. This is how services run, right?
Yeah. No, this is awesome. So I've been playing around with the idea, which again, it started less as a home lab and more as I want to try out embedded NATs or NATs on embedded devices. So not
Okay.
necessarily an embedded server,
Yeah, I feel like
but
it could probably right into that too, because some people, when you say embedded, they think embedded devices. Others think embedded in the application.
right.
Those are
Right.
both valid use cases.
Yes, it's a important distinction here. But yeah, that's my thinking is, I've got some ESP32s, so I've got these little sensors and I want to try just setting up very low level basic, sensors in our house where you got like temperature, humidity and things just to mess around with that. But then after talking to you, I've got, full home lab thoughts on my mind now where it's like, oh, okay, no, this is actually pretty nice. We can set up a media server and a bunch of stuff that I've intended to do in the past or I've done in very hacky, like simplified ways. But it's like now I've got multiple reasons, both for actually leveling up some of the tech around my house and getting, centralized storage and doing some automated backup stuff. Like that'll be nice for all of our computers. But then diving in with more of this kind of, less practical, more having fun with tech bits where I get to do some embedded C and Arduino things with, trying out the C client for NATs and sending messages through there versus MQTT. So
For
I'm
sure.
excited to dig in a bit more. And again, talking to you is a super helpful kind of high level overview. I know you've got a meeting to get to, so I
Yeah,
don't want to
I'll
keep you
drop it
too
in there.
long.
But yeah, I mean, having a lab is such a great sandbox. It's just you get to play with whatever you want to. So I've learned so much from mine that I've always encouraged friends who are interested to give it a go. You don't need a ton of hardware to get started. So and on the
Yeah.
32 note, that mini split in the background is a little bit older, and so I don't have any way to control it directly other than the remote. And I'm not a huge fan. You can get like connected IR emitters, but I don't love that. So anyway, there is a project where some of these you can solder in an ESP32 onto the board, and then connect that in. I still need to double check if the board I have actually has the headers that I need to do that. But that was one of the
Okay,
things
yeah.
I have some ESP32s, and that was one of the things I wanted to do with that. Was to connect in our mini splits because I have no way to. I can control our central HVAC right now, but I can't control the mini splits we have without using just the old remote. that would be fun.
Interesting. So they let you just slot in an ESP32 and then use
I
that
mean,
to.
you have to solder it, but there are like control
Right.
pins, and then those things are so infinitely configurable that like if you can get
Right.
if the pins exist there, then you can kind of configure it however you want. And there is actually an open source project as there for everything under the sun. There's an open source project for working with these mini splits. So
Man,
yeah,
that's awesome.
there's a rabbit hole everywhere you look, but I prefer that to the alternative, right? I'd rather have too many interesting things to do than not enough. So
No, 100%. Yeah. And this is, especially for me as well, having less experience with Kubernetes clusters in particular. I've done a lot of Docker. I've done less like Kubernetes orchestration
mhm.
or more like maintenance. I've worked with a lot of clusters, but usually with DevOps teams where they were doing the initial setup. And that was something being at KubeCon last week. I was hyper aware of how shallow my knowledge was with stuff. And Homelab is a really cool, like, as I've been, digging in a little bit and starting to go down the various rabbit holes. It's like, yeah, most stuff in Kubernetes, you can actually kick the tires on really well just doing a basic Homelab setup.
Absolutely. Yeah, you can experience, other than going to like really large scale, you can experience almost everything just on, Raspberry Pis or laptops or, whatever you have around your house. You don't need a whole lot to get pretty good if you want to. So,
And
anyway.
it's a super fun learning journey too, as opposed to like most of the times I've done Kubernetes work in the past, it was like for one specific, app that was already containerized and it was some crazy niche scaling issues or like that's always really difficult problems to dig into. Where this felt like, as I started reading, it's like I can see how just doing the basics of a Homelab will kind of drag me through the fundamentals of most Kubernetes pieces. You know, like I'm gonna have to do most of that at the introductory level. I don't need to worry about scaling. I don't need to worry about, you know, hyper optimizing scheduling and resources and all of that. It's more of just, let's get everything talking together. Let's, you know, practice with bringing everything up, with coordinating the pods. So I'm excited to dig in more with that.
Yeah. No, yeah, and obviously I'm happy to chat with you about it as you go on that journey. So anyway, I'm going to drop.
We'll definitely have more.
Thank you very much for having me on. And
yeah, thank you for joining us.
Yeah, I'll talk to you later.
All right, appreciate it. See you, Sam. All right, so again, that was Sam Attwood, and as I mentioned as well, we mentioned the Slack a couple of times, but if you enjoy any of the conversations here on Office Hours, first off, again, for the recording, we're going to get this uploaded on YouTube. The live stream connector failed today, which we've had about a 50% rate on that, but yeah, I'll get this re-edited and re-uploaded. I don't know about edited, but we'll get this re-uploaded as a video. And with all of our Office Hours, if you see somebody on Office Hours and you enjoy what they're sharing, you have a follow-up question, or you are curious about more information, at Slack, NATS community slack.nats.io is the best place. So again, you can find people in the general channels, hop in, introduce yourself. Like I said, I think the community is around like 9,000 people, and we have hundreds of monthly actives. So really, really strong NATS community. But additionally, most of the people you will see on this stream, that you'll see in Office Hours, pretty much everybody working at Synadia is in that Slack as well. So if you see somebody and they mention something, or you wanted to get more resources or get a link that we touch on here, again, a great stop is to head into the NATS Slack and just shoot a DM off even. You'll find Sam in there. You'll find myself in there. So yeah, if you have any, you know, targeted questions off of one of these recordings, or you are here live hanging out and you just want to dig deep, definitely recommend that. And yeah, actually, I just tabbed over and there's an example of somebody running NAT server and Linux in 10 megs of RAM on a Pico Mini. And that is one of the things, LuckFox Pico Mini. I assume that is a $9 mini development board. Okay, I was wondering if that was Raspberry Pi as well, because I know they've got the Pico. Holy tiny computer. Yeah, 64 megs of memory. So that's part of the embedded NATS use case that I find super compelling. And again, I haven't had too much of a requirement for it in terms of, like, even these ESP32s that I have, you know, they've got decent storage. They're not the most extreme resource constraints, but I am curious in playing more with resource constrained environments as you have on embedded devices. And there's quite a few options actually for incorporating NATS. So we have a C client library. I'll go ahead and share screen again, kind of walk through some of this. So yeah, so we have, if you look at NATS client libraries, I should probably, that Firefox new tab page has a bunch of ads all the time. Was this the page I was looking for? So here is like the Jetstream enabled clients. So you'll see the stars. If you haven't seen this download page before, this is nats.io/download, and you can find all of these language clients. Now, some of these are less actively maintained. Everything with a blue star with NATS authors noted next to it, those are Synadia community maintained clients. So pretty much all of those are fairly up to date in terms of APIs with newer features, including Jetstream enabled. So that's the thing. When you get to the Jetstream enabled clients, which this was a NATS 2.2 release, you'll notice the list of clients is a lot smaller, and it includes everything there with a blue star. So that reflects sort of how up-to-date these clients are, right? A lot of the core maintained ones we're going to be updating and keeping in parity with the NATS server features as they're introduced. The Go client, if you haven't used it before, is oftentimes considered kind of the canonical reference client. Gets some of the new features and new APIs, I would say, the soonest. But we do also have first-class support, you know, Java, .NET, PHP, C. We've got a lot of these. Rust as well, I know. Tomasz has done a ton of work on the Rust client over the last year. But yeah, so like for starters, you can just use the C client, which I think maybe depending on your resource constraints, this might be a little tough for some hardware, like that Pico board. I don't know if that would fit within that footprint. There's also some NATS Arduino clients, which these are out of date. So I've been curious. I'm sure they wouldn't have, some of the newer APIs. I mean, this might even not have, probably doesn't have Jetstream stuff supported. Yeah, like this is 6 years ago, his last commit. But I am curious to dig in on this and kind of see, like, can I do some very basic messaging examples? Here they've got the Echo, so I was looking at this before, but they've got the Arduino NATS is where they're pulling stuff in. And it's fairly straightforward, right? I mean, they've got publish and subscribe, and then an on connect. So this is something I've been curious of tinkering around with a bit. But again, the C client library may be a better option at this point, assuming that it works for your device within the resource constraints. And then, where was the other one? Well, the other bit is just using NATS as an MQTT broker. So, of course, you can also use a lot of these embedded devices have different libraries for MQTT communication. And if you've got NATS set up as the broker there, that's another pretty easy way. Which that was something that we talked with a lot of people at KubeCon and was surprised there was not the most awareness of being able to use NATS as an MQTT bridge. So yeah, this is something. Fun fact, if you don't know, do we have dark mode on these docs? Might be a browser thing. Anyway, sorry for the flashbang. But this is something that's pretty cool, is that NATS supports MQTT. It follows as closely as possible the 3.1.1 specification. And I know that we are, I believe this is dropping with 2.11, but we have upcoming Sparkplug 2 support. So if you're unfamiliar, Sparkplug, right? Yeah. Sparkplug is an architecture and a specification. And Sparkplug 2, surprised I didn't get it off of here. Eclipse working group. Yeah, it's under Eclipse. So this is the Sparkplug specification. Yeah, version 2 is what they're on. So this we will be shipping, I believe, with the 2.11 server updates. But otherwise, like we said, it's pretty close to the 3.1.1 spec. And this is just a cool, a cool way to connect with existing MQTT systems very, very simply, because you don't have to change much from that perspective. Any client libraries, anything in that ecosystem that's working, it's going to continue to work. You're just now leveraging NATS as the, and they've got the docs page here is really good for going over some of the details, some of the parallels between the two systems, gets into some of the configuration here as well. But yeah, there's a lot of really cool use cases here. And like I said, I've got some hardware. I've got like wires and breadboards and stuff starting to spread in my house. So I'm sure my wife's going to love that, but really enjoying going down the hardware rabbit hole a bit and setting up these. Well, I've got a couple different ideas for the applications we're going to do, but initially starting with the Homelab and kind of interconnecting some things, getting a couple nodes networked together here. But then the sensor mesh is kind of the thing I'm looking to do with the embedded stuff. So the ESP32s, putting those around our house in a couple different spots for, synthetic data. So having the sensors for actual temperature and humidity and stuff like that, but setting up a couple things like motion sensors or, tilt sensors, vibration sensors, even weight sensors for things like a phone. So my thinking is, could basically walk into my bedroom, put my phone down on a specific surface that has like either an NFC reader and I have a little NFC tag for my phone, or I've talked about doing like a scale so it can detect. So like if I walk into a room and put my phone down on a specific surface, that'll basically authenticate me as being in that room. So there's little things for this where I think it would be really fun just to like do environment gamification. So like I have my reading chair, having it detect when I sit down in a reading chair to read and how long I read for. I'm really curious in kind of passive, analytics collection like that. And so being able to time certain things around the house, being able to have certain triggers within the environment where it's kind of these environmental gates for data and getting that data into a system for actually playing around with. So I've got plenty of ideas, and some of that we may be building in the coming weeks, partially on stream, maybe some in office hours, although we actually have a fair bit of agendas for upcoming office hours as we lead up to the 2.11 release. And as always, I mean, I really like topical things like this and digging in on various topics that, people here at Synadia are really passionate about and have cool examples of deploying NATS in novel environments, or just having fun use cases and playing around with, different projects. Like we had Dawn, who ran a full lighting system at a camp over NATS. But in general, the rest of this year, we're going to be doing a little bit more of deep dives on various 2.11 features. And then probably early next year, getting back into some of the experimentation stuff, or just touching on different topics, different deployment targets for NATS, different use cases. So that's something where we do want to collect feedback, and we want to invite, ideas, questions, and suggestions from the community as far as what you'd like to see on the office hours. As always, we want to keep these as kind of a general Q&A. We also know when we have people on and we are touching on a specific topic, sometimes it's less conducive to the open Q&A style. So we like breaking things up sometimes, having like 30 minutes of presentation and 30 minutes kind of work and talk through different questions and Q&A items. But yeah, like I said, I'm excited for the rest of this year, because we're going to be seeing a lot more. We'll be seeing a lot more specific content leading up to the release of 2.11. So digging in and playing with some of the new features, or even diving in on examples and sample use cases with some of the new and upcoming features, I think is going to give a lot of context. Although if you're someone who's been waiting for these features, I don't think we're going to need that context to demonstrate the value. I think a lot of this, there's a lot of features that people have been waiting for, that people are excited for, or it's just matching things that you may be used to in analogs and other systems. And so things like per key TTL, I know, is one of those that a lot of people are excited about, getting that more fine-grained control over values in your key value store, being able to set up those caches, or caching rules, I guess, more specifically, more fine-grained control. But yeah, we've got quite a few things coming up. And we've also had fairly quiet chat today. Y'all have not had too many questions, so we may dig in more. We may do another Homelab episode in a couple months here and kind of revisit this and go over a bit of my Homelab at that point. We'll see how I've kind of set things up. But yeah, anybody in chat have general questions on NATS specific stuff, on KubeCon? That was the other thing I was going to say. We could just kind of chat KubeCon and give a little bit of a recap there, which was, like I said, that was my first KubeCon. I had a wonderful time. I certainly felt less informed than a lot of people, because I'm less experienced on the Kubernetes side of things. Again, I've deployed systems to Kubernetes managed stuff in the past. I know all the basics of things, but man, there is some very, very, very smart people at KubeCon when it comes to specifically container orchestration, all of the tech that goes into that. And I just had no idea, too, like how much work is being done on various aspects, like the Kubernetes ecosystem. I think in general, like that scale kind of blew me away, which I understand a lot of it is from the operator's perspective. And there's a lot of DevOps people that are used to deploying large systems, various types of topologies, having to get a lot of failover in, or a lot of VR type stuff, or even just the scalability and kind of the dynamic scheduling of resources. It's just super fascinating. JLMX in chat, so would love to see your home setup. Maybe this is the way for me to dip my toes into Kubernetes. Yeah, that's basically what I'm looking forward to, right? Because I haven't set up and configured pods from scratch, and I've already got a couple ideas. So like I said, I have a very old Raspberry Pi. I have a couple ESP32s, including a dev kit with a screen, which is a little more powerful ESP32. So that one I'm interested to use as a bit of a control unit. And then the other thing that I have is old MacBooks, which I'm very curious. I know there's a couple barriers there to get those running well in a home lab, namely getting a MacBook, installing Linux and getting it running Linux, but then setting it up to run in clamshell mode with a power cable plugged in. So I don't know if there's like a battery bypass that I could do, or how, again, a Mac running Linux, there's certainly driver issues and things you can come across. The Asahi project has done great work. If anybody's unaware, if you're running Linux, particularly Arch on a Mac, Asahi Linux is a project where a bunch of people basically reverse engineer tons of Apple APIs and hardware pieces to get it to run Linux well. And I think they've got a Calamares installer, which I think it primarily targets Arch. Yeah. But really, really cool stuff. Anyways, so that was one of my thoughts in kind of repurposing old hardware. That could be the start of my home lab, is take an old, 2019 MacBook Pro and just get it wired up, battery bypass running in clamshell mode, and put that in a closet, because that certainly would have enough resources. When I'm looking at like a Raspberry Pi as an alternative, it's like I can definitely use one of these old MacBooks. But yeah, again, I think that would just be a great way to really test my working knowledge of Kubernetes and kind of the 0 to 1 setup, actually building something and architecting that system a bit. So I'm excited for that. I think it's going to be, y'all should see my desk. Like, I'm literally just have a smattering of sensors. Like, here's one of those atmospheric sensors that I was playing with, and wires and stuff, because I am really excited just to tap into more of the hardware level. I've been in high level software development land for much of my career, and this is a fun back to basics moment for me, as well as just how useful NATS is in this environment, in this world. And that's part of my job here at Synadia, obviously, is learning and using NATS extensively. I think that's one of my kind of personal goals and objectives as well, is I'm certainly not the most prolific at Synadia in a specific deployment of NATS. I'm not the Kubernetes expert. I'm not the one working on the Helm charts or anything like that, but I am a polyglot that likes doing a lot of different things. And I think in my work at Synadia, especially as it pertains to kind of educational content and building some more video content going into the new year, I'm excited to have more experiments like this, kind of a lot of times probably scratching the surface, right? But giving a basic survey and overview of what it looks like to create a NATS cluster in these different environments, and or what it looks like to create a NATS cluster targeting specific use cases as well. So looking at kind of the IoT use case and home, like a home assistant kind of configuration, doing things with lights and what's the thing that controls the temperature? Not thermometer, but the things you use for your central air conditioning and heat. Thermostat, that's the word. But yeah, like what it looks like to actually network together those IoT home devices, what it looks like to network together a couple nodes and actually clustering those, multi-clustering, I guess, those into the cloud. Just a lot of cool use cases to explore there that, again, are like fairly practical stuff too. In particular, the way that Sam was leveraging, the leaf node configuration so that his cluster is actually accessible from the cloud, as opposed to like tail scaling it out. Like you could tail scale and make it accessible and get the traffic, but this is like a more NATS purist approach where you actually have the multi-cluster and then you can configure the traffic appropriately, so you're not just mirroring and sending everything over the public internet, but you can kind of get a little bit of a fine-grained control over what information goes into the cloud and what information just stays in the local leaf node. But yeah, was trying to type thermostat, but the fat fingers get in the way. Yeah, no worries. No, this has been cool. I'm like, my brain has been packed for the last week. So ever since I got back from KubeCon, I've been looking into this. I've been searching for, mini PCs and Raspberry Pis and ordering some hardware and some sensors here. So might take me a little bit of time before I really have things running, but that's what I was saying, after the new year, I think is when we'll get in and really do some of these exploratory series on Homelab stuff as one of the first ones for sure. And then I also want to do some web experiments with doing like in-browser multiplayer features. I think that's another area that's going to be really, really intriguing, playing around with Datastar. which is like an HTMX-like framework, so a hypermedia-focused framework for web front ends. We're going to be doing some experiments with that as well here at Synadia for educational resources. So that's something I'm really excited for in the work that we're doing here, is getting into more like playground in-browser sort of settings where you can configure and or try different NATS CLI commands and stuff like that within a browser and actually have it be a little responsive. So there's some cool stuff on the horizon for that. But yeah, like I was saying, I think the rest of this year, we're really gearing up for that 2.11 server release. And so you can expect probably a couple office hours from now to the end of the year. Next week is Thanksgiving, so likely a holiday week, likely will not have an office hours, although stay tuned. We may try to schedule one in a different day for next week. But certainly going into December, you can expect to see some, upcoming feature discussions here. And yeah, just looking forward to the 2.11 release and doing some deep dives as well. A little bit of educational stuff on using some of those new features and what that could look like. Yeah, anything else? I was trying to look back. We have some old agendas and stuff, but we're close to the top of the hour here. Like I said, I'm excited for coming back and revisiting this topic. Once I've got some more hardware, I've got a couple things on order right now, but once I've got some more things distributed through my house, and I'll go through some of the pain in setting up the cluster and setting up some of this orchestration. So I'm excited to share lessons learned from that. And I feel like there was another announcement or something that I was going to touch on. As per usual, the major shout out is the NATS Slack. You can probably see this in the chat, so I'll copy and paste one more time just in case. And as always, thank you for joining us. The live stream on YouTube didn't go out today, so I'm going to re-upload, so you'll be able to find this episode in the videos on our YouTube, that is, which I can also paste that. If you have not seen the Synadia YouTube channel, there's a lot of just fantastic content on there. Jeremy has done all of the videos on the channel. Wait, did I copy the right link? Yeah, there we go. But yeah, Jeremy's done some fantastic video content. I am picking that up, so I will be releasing at least a couple videos before the end of the year, and then going into next year, we're going to lean into that a lot. If you're familiar with NATS.fm, that was the other item that I think I wanted to mention. NATS.fm is a podcast, and the last episode, I believe, was beginning of this year. Yeah, January. Yeah, so it's been on a bit of a hiatus. Synadia.com/podcast. which I believe is just if you go to nats.fm. Yeah. So if you go to nats.fm in your browser, that's a great way to get there as well. But that gives us, that is a podcast format. Again, I might be duplicating messages with the Riverside chat here, but that's a podcast format talking about NATS, talking about developing different things. And as I said, with the 2.11 release coming up, I believe we're going to have some of the first episodes of the new season of Nats.fm doing some of these deep dives, discussing some of the upcoming features, discussing the 2.11 release in general. But that's another thing to keep an eye out for. So I believe first episode is being recorded tomorrow, and will probably be up either late tomorrow or early next week, with the weekend coming up here. So yeah, that puts us at the top of the hour. I think that's everything I had to touch on today. Bit of a brief stream today, but we again had Sam in here. And if you have any questions, feel free to reach out to me. You can always find me in the community Slack. You can also find me on Twitter. This was fun. I'm excited. Again, I feel like I'm drinking from an ocean with some of the Homelab stuff, just because there's so much. It's such a deep topic, especially if you depending on how far down the rabbit hole you go in any one of the dimensions. But I'm excited to dip my toes and, like I said, get, I think running NATS on more architectures is kind of my goal this year. Sort of like, how many different architectures can I deploy NATS on and get systems and clients working? And so doing the IoT and home stuff is definitely opening up a couple more novel use cases where I get to use client libraries I would not otherwise use. But yeah, this has been a blast. Thank you, Scotch16 over on Twitch, for that follow. Appreciate that. And we will be back in the future. But I hope everyone has a wonderful rest of your Thursday or Friday, if it's already Friday for you, depending on where you are in the world. And we will be back next week for in 2 weeks, we'll be back for an office hours. We may have an off-schedule office hours next week. And keep an eye out for that NATS.fm new season, new episode dropping within the next week here. So with that, I hope everyone has a wonderful Thursday, and we will see you on the next one.